Hey guys, welcome back to the channel. I got a new project here. This was for full transparency, a project that I was not going to upload. I didn't think there'd be any interest with it. It's a 95 Mustang with a 3.8. It's probably the biggest boat anchor of an engine you could have. I think a lot of these just get swapped for 5 liters, 4.6s. I'm not really sure if there's a huge audience for people wanting to rebuild a 3.8 V6. But the backstory on this car is, this is my wife's uncle's car. It's got 74,000 original miles on it. He's had this car, I don't want to say since new, maybe. I actually don't have the facts with that, but he's had it long enough where he raised his family in this car. His kids grew. He now has grandkids. I mean, those kids are 10 plus years old now. Up until last summer, he was driving them around in the car, going to get ice cream, going to the beach during the summer. The motor unfortunately let go last summer. He tried bringing it to all the garages or calling around to get somebody to get a motor for him, but it's a 3.8 V6. Nobody really wanted to work on it. The prices he was getting was kind of we don't want to do it, but we'll do it for this price, $10, $12, $14,000. So I decided to take this project on for him. Has a lot of sentimental value. The car's not worth anything. I mean, I could buy this car with a 3.6 in it for probably like $2,500. They're still kicking around here and there, but it's not his car. So I struggled to find an engine. I took the motor out. Right now it's May. I took the motor out last December, tried to find a Jasper engine, tried to find a good running 3.8. The 5 liters are still kicking around. Even those are starting to get sparse, actually. But I didn't want to do a swap. I mean, there's so much more to it. It sounds easy, just drop a 5 liter in it, but talking ECU, suspension upgrades, cooling system, there's all kinds of stuff. I really just wanted to put a drop in, but unfortunately, I couldn't find one. In 94, 95, they only made them these 2 years, and they had so many issues with the head gaskets that I don't know if there's any good ones running around anymore. I scoured the earth trying to find it. I couldn't find one. A lot of people on the internet said that the 96 to, don't quote me, I think it's 98 only. It could go up to 2000. And then they switched to the, oh geez, I can't remember what they call the New Edge, I think. Or I think it's the New Edge engines was either 2000, 2001. I mean, you'd have to look that up. But I do know 96 to 98 was quote unquote the same engine drop in. There's really not much of a difference. But I can tell you I could not find 94, 95. I looked everywhere. This engine has 2 spun rod bearings that are spun so bad. I mean, the crank is destroyed. It's beyond turning it even 30 or 40 and putting oversized bearings. So I ended up finding what was supposed to be a drop-in good, and you could tell by this strip block right here that was not the case, but a drop-in good running 3.8 out of a 98 Mustang with 60,000 miles, and I could tell you it was not even close. I'll show you in a second. And they should be the same. Everything should drop in. So I'm going to show you some of the differences right now. Obviously, I got ahead of this project. Like I said, I wasn't going to film it. So I removed the engine, got it on the stand. I was hoping the bearings weren't going to be that bad. I was just going to bring it to the machine shop, have them turn it down, put oversized bearings, and send it. But that is not the case. So I ended up with this 98. So if you're curious, here we go. This is the difference between 94, 95, 96 through 98, possibly 2000 before they came out with that new Edge engine. So some of the differences here, it's easy to show you right on this table. So on the left side, the left cardboard is the 94, 95. What's interesting, this was his motor. You can see that oil pan doesn't even look too bad. What I think realistically happened, I think the oil level got really low. And I can tell by all the oil leaks on the cross member. Looks like there's a gallon of oil everywhere, so it's been leaking for a long time. I think he stopped it for some oil. It sits all winter, fired it up, drove it without checking the oil, and ended up running dry, is my guess. So this is the 94, 95. This is the 96 to 98. And look at that oil pan. I mean, this is what came off the junkyard motor. I mean, it's in horrible shape. So I pulled that off, and I'm like, here we go. I mean, all the aluminums was, I mean, so corroded. Just everything I took off was in really poor condition. It got to the point that I knew I was gonna have to rebuild this thing. Looking at the bench over here, where that cardboard box is, that's all 94, 95. To the right, 96 and up. And all this stuff is just junk. I mean, all the fuel rails were all rusted. I mean, everything's just in really poor condition. The tension, I mean, that tensioner ain't tensioning anymore. And this was supposed to be a drop-in. But hey, that's how the cookie crumbles, right? So, to show you some differences to the 94, 95, let me start at the table here. So some of the things I can show you is, look at the cam sensor. So the shaft, the gear, the length, I did all the measurements already, so this is all factual. That's all the same, but the top, the actual sensor, you'll see, is different. You got a small cap to a big cap. So how I'm gonna mitigate that is use the old one. So this will. So the time and chain covers are different. I could just show you just with this water pump. So I can put this water pump on there, it lines up. Go and move it over to, I mean, it's not even close, the 96 and up. So you're gonna decide which timing cover you're gonna use. So the one that came off the 94, 95 is in better shape. So I am gonna use that. Crank balances are the same. So I'll use the 94, 95, it's just in better shape. The oil pumps are actually different, but like I said, I'm gonna use this cover. So I'm gonna use 94, 95 oil pump. The balancer pulleys were different. I'm gonna use 94, 95. The oil pans are the same. When they dropped off the engine, they actually dropped it and broke the air. This air off this oil pan that looks horrible anyway. They broke that off, so I'm gonna use the 94, 95. So I should be good there. I can use that oil pan. I can use the factory sensor. I can use this timing cover, like 94, 95 water pump. Use the old oil pump. The rebuild kit that came with the engine rebuild kit came with a new oil pump, but unfortunately, this guy here, it has to go on this timing cover. So I have to decide if I want to use the new oil pump. I'd have to reuse this timing chain cover, but in my opinion, that one's in better shape. So I haven't 100% decided what I'm going to do yet. The crank sensors look the same, so that's good there. If not, I'll swap those over. But yeah, that's actually one I wasn't thinking of till I'm filming this now. I was planning on using the 94, 95, but then I can't use the new oil pump. That is different. That bolt pattern's completely different. The dowels aren't even in the same spot, so that was changed. So I wonder if the oiling needs a different for the 96 and up. So just thinking this out while I'm making this video, I am probably going to use this cover just to make sure I can use the new oil pump and it be the right pump for the top end of that engine, because that brings me back to another difference, is the heads. The heads in the 94, 95 are definitely different than the 96 and up. The bolt pattern's completely different. If you see, you got 1, 2, 3, 4, 5, 6, 7 bolts. And then you go to the heads that came off the 96 and up. It's got 1, 2, 3, 4, 5, 6. It's actually got one less bolt. I already put the lower intake on the 94, 95, and they're different. So the lower intakes are different. This is off the 96 and up. You can see again, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then you come over here. This is the 94, 95. You got 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So I can't use the 94, 95 lower intake, the original intake, on the 96 and up heads. And I'm definitely going to use the 96 and up heads on that engine. So one thing I can tell you is the upper intakes are exactly the same, minus the, let me turn this light on here. Minus the throttle body and the sensors, stuff like that is different, but the actual casting of the aluminum is exactly the same. So I'm going to use the 96 and up lower intake, and I'll transfer all these sensors over from the original intake to the new style, the new edge engine. I'm sorry, not new edge, to the 96 and up engine. And I'll use the original upper intake. I'm going to use the original injector rails. A lot of the original parts I should be able to utilize. So what I did was I broke this 96 and up engine already all the way down, as you can see. I already cleaned it. Cleaned it very well. I took out all the bearings. Cam bearings are out. The only bearings that actually looked like they were in bad shape were the cam bearings. Rod bearings, the mains, those actually looked awesome. Show you over here. The rockers I'll reuse. I think the kit came with new push rods. Not 100% sure. Came with the new freeze plugs. These are the heads, 96 and up. They have to get cleaned up. Here's all the lifters. This is all 96 engine components. The timing chain tensioner, I'm going to get a new one of those. The kit did come with a new chain timing gear set, so I'll use that. The original cam's in really good shape. I'm going to reuse that. Lifters I am going to replace. They are in good shape, but it's definitely the hydraulics it's a wear item, so I'll replace that. The pistons, it did come with new pistons. It's just to press the wrist pin out. I don't have a setup for that. So I'm going to try clean. I mean, I barely wiped these, and they actually cleaned right up. They look good. So I haven't 100% decided if I'm going to replace the pistons. And to me, the casting on the new ones aren't as good as the OEM. So I don't know what I'm going to do there yet. We'll see. Here's the, just one of the, all the rod bearings are the same. They look awesome. They look really good. Doesn't look like any trash got into this oiling system at all. So I'm definitely gonna reuse these rods. Definitely gonna re-ring it either way, if it's got the new pistons or not. We'll see how these clean up. Mains, same deal. The mains look really good. If you can see that, you can see some wear, but I mean, there's plenty of babbits, not worn down to the base at all. Uppers and lowers looked really good. Obviously, there's some oil on there, but yeah, they're in good shape. I'll show you one of the cam bearings. It's one of the worst ones. This is what I'm saying by the base. You can see right down to the copper, if I can get it just right there. So you can see the babbit, and then it right there, it fades right down to the base metal. So that'll hurt oil pressure for sure. So these are gonna get replaced. Everything's gonna get replaced, all cleaned up. And then here's the kit. It's a DNJ kit. Comes with everything. Brand new oil pump, timing chain set, the new pistons, and wrist pins. I mean, if I have to, I could probably bring those down to a machine shop and have them pressed for me. These are the new pistons. Ring set, cam bearings, main bearings, rod bearings, and then a full gasket set. Trying to see if there was the years on here, because I can't remember without looking it up. 96 to 98 or 2000 before they came out with that new Edge engine. So that's where I'm at. So we're all cleaned up. So now I'm starting to reverse the process. I'll be able to film the rest of that. Obviously, I got ahead of myself with the breakdown, but I mean, if you're getting this far, it's pretty straightforward. Another thing too, these have like these dog bone retainers for the lifters, the 94 to 95 3.8. the 96 and up actually use kind of like an LS engine. They use lifter trays, which I thought was interesting. It's just pretty much the same deal, using trays. So now that I'm cleaned up reversing the process, what I'm going to do is do the freeze plugs first. The main reason being I'm going to be whaling on this thing, and I just don't want to ruin any of the thrust surfaces on the bearings. And I may have to take this off the stand and put this block down on the ground, timing chain down on the ground on a piece of cardboard to hammer in these back plugs. So I got 4 to do in the back. This one, the same thing on the other side, this guy, and then the behind the cam. So I'd rather do that while there's no weight and nothing I could damage. Then I'll put it back on the stand, make sure we're nice and clean, oil it again, and then start reassembly. So a couple more things before I keep rolling here. How I clean this, I used that engine degreaser in a can made by Gunk. While it was stripped down, I soaked it really good. Then I actually pressure washed it. That got out basically everything. I had this tote underneath it catching all the oil and grease. And then I hit it with brake clean. Then I blew it all out, and I immediately soaked the whole block in WD-40. I just sprayed the whole thing so it wouldn't flash rust. And that's how I got it to the way it is right now. I mean, it's super clean. Came out really good. And this engine was really caked. You can see like the discoloration here, how dark it is. That's just because oil was sitting there for so long. And then back to this timing chain cover. I have decided that I am going to use the 96 and up on the 96 and up for a couple of reasons. One is I want to make sure I use this oil pump because I don't know if this top end, the heads are different, which we can clearly see. So I don't know if the oil and demand is different. So I don't want to mess with that. I don't want to mess with the flows. If I just reuse this timing chain cover, I can reuse that oil pump. I don't have to think about it anymore. That's what it was engineered and designed for, so that's what I'm going to go with. And then another thing is the 94 to 95 had head gasket issues. And if you look at the difference, look how much larger the water pump is between the 94 and 95 and the 96 and up. So my guess is this pushes a lot more volume of water through that block versus the 94, 95. And again, this is the 94, 95 water pump. It fits on there, all the bolt holes line up. And then when you try putting that on the 96 and up, it's not even close. It's a lot smaller. So this is making a lot more sense. Either I'm going to reuse this one or I'll buy a new one. So yep, I decided I am going to stick with the 96 and up timing chain cover so that I can utilize the bigger water pump and the correct oil pump and not have to think about it. The cam sensor, I already checked, will drop in. The 94, 95 will drop into the 96 and up. I'm not sure if I can no, I can't just replace the cap either because the way it's bolted on, see how wide it is? And where it bolts into that aluminum housing, it's spread pretty far. And if you look at I mean, it's night and day difference. This one's a lot smaller. But this will drop in. I took all the measurements. I used a dial, counted the teeth. The rods are all exactly the same, so I don't think I'm going to have an issue just dropping this in, the 94, 95 camshaft sensor, into the 96 and up timing chain cover. But, hey, we'll find out. Yeah, so that's just some differences. There are quite a few differences, honestly. You can't just drop this thing in and plug it in. A lot of the sensors are different, so there's quite a few small details that you have to really think of while you're doing this. But it's at the point, maybe it would have been easier just to put a 5.0 in this thing. But we'll see how it goes. All right, so to put these freeze plugs in, there is a tool to actually install these. I mean, there's a tool for absolutely everything, or Cornwell tool would be out of business. All I do is I take a socket with an extension, a socket that you don't want to get one that fits very tight, because as you hammer this in, it actually compresses the hair. It'll compress onto the socket, and you'll have a hell of a time getting the socket out of the freeze plug. So I just grab one that's a little loose, and all you're gonna do is, before you do that, around this edge right here, all the way around the sealant surface, you're gonna use Permatex high-tech gasket sealant. You're gonna put that around the edge. That is gonna be a sealant, and you're gonna use this just to start hammering it into the block nice and square. Obviously, make sure your block's nice and clean all the way around. There's no crud in there, which it is. You're gonna put your sealant on. You're gonna hammer that in, and you're just gonna start it, lightly tap it, nice and square. And once you have it seated in there, then I swap this socket out for a bigger socket that'll actually sit over the whole plug. So you're not pounding this thing in by the shoulder. You're actually pushing it from the outside, and then I'll tap this in. And the socket being bigger, it'll actually stop on the block, and it'll sit flush. All right, so that's the freeze plug started with the socket, and now I'm gonna drive it home with the socket flush, just like this. And then it's gonna bottom out itself against the block, so you can't recess it too much. You can see the shellac on there on the edge. And then I do something I hate to even admit, but it's just OCD. If you look at that dot right there, I actually put where I want the top of the plug to be, so that this is actually facing the right direction, like that one. Yep, that's OCD. Yeah, so that's it for the freeze plug. Pretty straightforward. That one's seated. I have that one in, so the front's done. Now I'm just gonna do the rears, and that'll be it for the plugs. All right, so I got all the freeze plugs in. I'm actually missing two. I got the galley oil plugs and freeze plugs in. I got the fronts done. The rears are done. This side are installed with the plug, but this side has nothing because I was missing two. So I'm gonna have to get 2 more 1.5-inch freeze plugs, which is fine. I'm also gonna order a flex hone with the new cylinders. It looks worse than what it is. I mean, that's just oil. I would like to hit this with a flex hone just to get a cross hatch with the new rings. Installing new rings with this bore not touched is not a good idea. It'd be a good idea to get a cross hatch so those rings can wear in and seal. So I want to give this thing its best fighting chance to be successful. So I'm gonna order a flex hone tonight. Should be in tomorrow, and then that'll be my next step. And I'll also order the 2 freeze plugs, which is a quick job popping those in. It's getting there. There's 2 reasons why you want to deglaze a block. Number 1 is over time, this engine's operating, the rings are so tight in these cylinders, there's so much pressure on the cylinder walls from the rings, it ends up polishing the surface of the walls. And when it does that, it doesn't allow the oil to adhere to the cylinders as well. So by cross-hatching, you're basically roughing that cylinder up enough so that it gives something for the oil to adhere to, so there's more time for that piston to stroke with an oil-soaked cylinder, so there'll be less friction. And the second thing is the rings themselves. So when you replace rings, you put new rings in. The cylinder wall, if it's mirrored, has a mirror finished, smooth surface, those new rings are basically just gonna skate over that surface. They're not gonna wear in, it's not abrasive enough. So when you put that crosshatch in and you hone these cylinders out, it gives just that minute amount of surface to wear into so that those new rings will wear into the cylinder walls. So it's something that has to be done unless you like blow-by. You don't want the combustion gases getting by the rings. You'll end up overpressurizing the crankcase, and you'll have all kinds of issues. So definitely want to deglaze the cylinders if you're getting to the point where you're freshening up a motor and re-ringing it. So the tool we're going to use here is this flex hone. It's manufactured by Brush Research Manufacturing. It's also called the Dingleberry hone. That's what we called it back in vocational high school. Here's the name of the company. So on their website, they have a bunch of charts, application charts, to size what hone you need, what grit you need, and what material you need. So looking at that chart for a carbon steel block, carbon steel cylinders, it calls for a, you'll see SC here, that's silicone carbide. And the grit that I'm using is 240. There's actually a standard grit for doing exactly what we're doing here. So I just went right into the middle, went with 240. And then the size, the size doesn't matter to everybody here. It's specific to your block. This is a 4" and 1/8 hone. And what you do is after you measure your cylinder wall, you're not going to get, well, you might get lucky, get the exact hone you need. But what you do is whatever size your bore is, you just want to get the next size up hone. So for example, if this is exactly a 4" bore, you'd go with the 4 1/8" hone, if that makes any sense. They don't make them specific to every bore, specific tolerances. They have a lot of give in them. That's why the abrasive is so far away on the wire. So it's basically, I mean, unless you really undersized it or oversized the hone to the bore, you're basically putting the same amount of stress on the cylinder walls either way. So super convenient. Right on the box is the instructions. The instructions will differ by the diameter of the hone, basically. So it's telling you to use a 10, 30 weight oil. You can buy their oil, cutting oil. The flex hone tool, rotating upon entry and removal of the cylinder. You just want to make sure it's rotating as you're putting it in the cylinder and as you're taking it out of the cylinder. And the big reason why is if you just push the hone in, you're going to score straight down, and if you pull it out, you're going to score straight out. Obviously, the piston rings seal the diameter of this bore, and if you were to put a nice little scratch straight down and not polish that out or hone it out, now you have somewhere for exhaust gases to escape down into the crankcase, which you're just going to overpressurize the crankcase, have blow by, and that'll be a bad day. So definitely have it rotating as you're putting it in the cylinder and taking it out. The recommended RPM for this diameter hone is 500 to 800 RPM. I'm just going by the drill. It has a little chart on the side. It's a 3-speed drill that I'm using. If you don't have that, try to look up your model number. The RPM is important, so I would try to get into that spec if you can. Use 60 to 100 strokes per minute, depending on RPM. Final stroke, it may be accelerated to develop a 45-degree crosshatch. So if you look, do not use solvents, clean cylinders. Oh, I skipped right over it. Honing time should be approximately 20 to 45 seconds per cylinder. So basically, every stroke is a second, right? So I basically do about 20 to 30 strokes every time is going to give you 20 to 30 seconds. So that's how I do it. 20, 30 strokes. I know I'm in the 20 to 30 second range. And then the last 5 to 10 strokes, I'll do those very fast to get the 45-degree crosshatch. And if you go nice and slow, it should make perfect sense. If you go slow and this thing's rotating, you're just gonna get fixed lines all the way down and all the way up. So when you pull it out, it's just gonna look like a bunch of lines. But on the final 8 to 10 strokes, you go nice and fast. Now you're skipping so much cylinder that you'll get a nice 45-degree hatch. Another thing to think of, if you wonder why I put masking tape on there, you don't have to. I just do it. I cleaned this block once very well. I soaked it, hit it with the pressure washer after scrubbing it, and then I hit it with solvent, then I hit it with air. And then after I do all this, I am going to clean it again, but not to that extent. So the reason why I taped it off is I don't want all the oil. You will get oil coming out of the cylinder as you're putting the hone over. You're going to get this deck covered in oil. I like to just put tape so that the coolant galley doesn't get a bunch of oil in it. I know I can spray it out, try to get it out, but if I can mitigate how much oil goes into the cylinder walls just by simply putting tape, for me, it's just easier to clean up after, that's all. The prep is everything. And with that, before you even start this process, so I've already done this one cylinder, and if you look at the bottom, see how it's nice and clean all the way down? Now here's the next one. You can see where the piston ends, and you can see where carbon buildup, where the skirts are, right here. So that's all caked on oil. You want to get all that off. You basically want to clean these cylinders to the point where you can put a clean cloth with brake clean on it, wipe it, and when you take it out, it's still clean. That's when you want to start honing. And then after you're done honing, you do the same thing. You get it so it's a clean cloth coming out, then you can oil the cylinder. So I'm gonna hone all three of these. This one side, I still gotta clean these two cylinders. I'll hone them, and then I'll clean them all at once. It doesn't make any sense. One thing to think of, you don't want to do one cylinder completely, get it completely clean, and then move on. And then now you have oil and grit splashing in there. Now you got to do it all over again. So I like to tape off one deck, get all three cylinders nice and clean, hone all three cylinders, clean all three cylinders, then oil all three cylinders. So that's how I'm going to do it. I got ahead of myself on just this one without cleaning these two, just basically to make this video to show you the difference. So this is one cylinder honed. You can see there's still some staining right at the very top. So I got this from a junkyard. There's probably sitting a little bit of moisture in there. So I might hit it one more time to try to get that out, but it's in pretty good shape. And if you look right here, I don't know if you can get this in the camera with the angle. You can see the cross hatch, and it really cleaned it up. This is about 20 strokes, so I have another 10 to go. So I will hit it one more time and go very quick, probably with the last few, and see if I can get that staining out of there. And then just for comparison, this is 20 strokes after it was clean compared to one that I haven't touched yet. You can see how dirty that is. You can actually see how it's polished. Let me see if I can just wipe that a little bit. On the side, you can see how shiny it is. So those no rings are just gonna skate off of that cylinder. They're not gonna wear in, end up with a bunch of blow-by. So I'll hit this one, I'll clean these two cylinders up, and I'll show you what it looks like compared to the other side. All right, hopefully this angle works for you. Do my best here to show you how I do this. So I got a bucket of oil, it's soaked in the oil. Let some of that excess come out, and then right into the hole. And you want to start rotating as you're putting it in. Nice slow strokes, 4, 5, 6, and I'm gonna go fast, 7, 8, 9, 10. And you want to continue to rotate it as you come out. All right, so you can clearly see the difference from afar. You start zooming in a little bit, see the difference from that cylinder to these two. It's night and day. So this is after roughly another 10 to 15 strokes. You want to, whatever you choose for the first cylinder, what I'm going to do is try to stay around there. So I know I'm around 35 strokes. That's what I'm going to do to the rest of these cylinders and see how they clean up. I like to keep them all around the same, but it's not perfect. You know, it's not a machine. You're doing this by hand. At the end, you want to get that cross hatch, and you're going a lot faster to get the cross hatch in. So it's not going to be perfect. But that's what's great about this flex hone. You're not going to get to the point where you can really over machine it and cause a huge issue. You know, but yeah, it's looking really good. So I'm gonna move on. It still has the oil in it from when I just honed it. I'm gonna leave that in there so it doesn't flash rust on me. I'm gonna clean up these two very well. I'm gonna hone those two, and then if I'm happy with what I see, then I'll just go right down and really clean them out, oil them, and then switch to the other side. The cylinder honing's complete. After I finished honing, before I started cleaning the cylinder walls, I actually cleaned all these surfaces. I cleaned the head surface, both heads, cleaned the timing chain cover surfaces, everything that you're gonna make a mess. You could do one final cleaning, but before you do that final cleaning, the oil pan gasket sealing surfaces, cleaned all those. After that was done and I knew I wasn't gonna be throwing any more debris around, I gave it a brake clean bath. So I ran about 2 cans of brake clean, hosing this block down into a bucket. Then I blew it all down with compressed air, wiped it down, and then hit it with 1 more can of brake clean just to get any final contaminants off the block. Hit it with compressed air 1 more time, then used WD-40 and soaked pretty much the entire block just to give it a coating so it doesn't flash rust on you. So after that was done, I wiped out all these cylinder walls. So what I did was I grabbed a towel, soaked it in WD-40, wiped it out, came out black, switched towels, kept doing that over and over again until you get to the point where you could take a white towel, put it into the cylinder, wipe the walls, and it come out white. You just want to get all the contaminants out of that cylinder. When you first fire this up with the new rings, these new rings are going to wear into these cylinders, and you don't want it to grab any contaminants and pull those contaminants up or down the cylinder walls. You're just going to end up scoring this, like I said before, and you're going to have combustion gas leaking past the piston rings and the cylinder walls, which, I mean, will defeat the whole purpose of doing all this work. So these are all clean. These are ready to go. My next stop's going to be installing cam bearings. So I got 2 cam bearings in so far. You can see I got that rear in. Next one in. I'm gonna be working on these last 2, but I figured I'd just show you how I'm doing it. So this is the tool I'm using. It's a Amazon, it's adjustable, which I'm not a huge fan of. With the LSs, I have a fixed one, so you're not fumbling around while you're trying to get the bearings on. But this is the kit I ended up using from Amazon. It is working all right. I think it was like 85 bucks. Comes with a bunch of different expanding drivers. Like I said, it's working pretty good. It's got the cone, so there's the expanded driver. So what you do is, I'll just slide it in through this one, so there is no bearing where I'm going through right now. So if you can imagine, this one's not installed yet. You slide the bearing on, get it square, put the cone against the front, and then you start tapping it in. Don't start driving right away. Make sure it starts square, then you can start driving it in. One thing to think of is the hole alignment. So what I do to check hole alignment, let me grab my flashlight here. So this first one, I looked at an old picture and it did have one of the holes lined up just off center of the oil galley hole. So you'll see there's 2 facing the top of the engine. This engine's obviously upside down right now. So there's one pointing straight up. So if you take a flashlight, point it into the hole. I don't know if this camera's gonna show it. I think it will. See the light in the center of the bearing show up. Then now it's gone. Now it's back. Let me see if I can cover the light here. It's not gonna let me do it. I wonder if I can prop this phone right here. Yeah, there we go. You can see it at the top of the screen, right? Let me get my hand on there. So I got the light on my fingers. It's gone. So now I know that I'm in the groove of the block. There's a groove that goes all the way around on this engine. And then if I take my finger and go up around and cover the hole, I can make the light go away. So I know I'm fully seated and I know oil is gonna come out of these 3 holes. It's just something to think of. I did the same thing with this guy, and I'm gonna go all the way down, just checking to make sure I'm all the way in. Here's another one. It's on the tool, the light, so you can see that the oil gallery goes all the way through. It's rifled, and if you look at the groove by the tool, that's the groove I'm talking about inside the cam journal, right where my finger is. That groove goes all the way around. So the oil's fed through this one hole, hits the back side of the bearing, and then comes through the 3. So you just want to make sure when you drive these, which every one I've ever done on every engine, the driving tool is basically flush with the block in the cam bearing. And you'll see that on both sides, the cam bearing's flush. Just a sanity check. You wanna really make sure you're getting oil to these bearings, or you're gonna have a failure pretty quickly. So I'm gonna drive these last two and that'll be it. All right, got all the cam bearings in. Pretty straightforward. Just gotta take your time, keep everything clean, well lubed, get your holes lined up. That cam bearing installer tool, the expanding type, worked pretty good. So this hole right here on your main, that center one, if you follow the casting, comes right down to oil this cam bearing in the front. And if you look, the hole is just slightly off-centered. That's what you want. The oil's gonna take the path of least resistance. So if you have that hole perfectly lined up, you're gonna get plenty of oil in on this side, but you want it to follow that channel all the way around to the other two holes. So it's just best practice to keep that a little off center so that it forces the oil all the way around that groove inside the block to feed the other two. Does it make a huge difference? I'm not sure. Probably high performance engines it does. With this it probably doesn't, but it's just the best practice. You don't want a straight shot right in. So what I'm gonna do next is start working on getting the crank in. I'm gonna get the main bearings installed. I'll get those lubed up, clean up the crank, drop the crank in, put the upper caps on, torque those down, and then I can start working on cleaning up the rods and pistons, re-ringing those, getting those installed. But one step at a time. We're gonna work on getting this crank installed now. I do want to mention one more thing with the cam bearing. So if you look on this sticker right here, it does matter where these go. So that part number that's on the cam bearing, 52-1, goes in position 1 and 4, so the front and rear of the block. And then 51-2 goes into position 2 and 3. You definitely want to check these, depending on what you're working on. They're typically always different. You don't have either 4 or 5 of the same exact bearings, so pay attention to that. When you remove parts, that's kind of how I have it laid out over here. I always do front of the engine towards me, away from the back wall, and I place everything as it came out. So when I'm either cleaning or replacing parts, I can notice a difference right away. There may not even be a difference, but I just don't want to take that chance. So all those rockers are exactly like that. The heads, these lifters, everything comes out and gets placed right back on the bench how it came out. Even the orientation of this to this plate right here, it's all the same. Just so I don't get caught with something in the wrong orientation. The pistons, same thing. That's exactly how they came out off the crank, right down the line. 1, 2, 3, 4, 5, 6. And I'll clean them that same way. I'll re-ring them the same way so that they go right back in the same orientation. Same thing with these mains. These are pretty straightforward because of the arrows. The arrows face direction, and the arrows are the number of the main caps. You have one arrow here, so that's forward. That's number 1, 2, all the way down. 1, 2, 3, facing this direction, and obviously the rear main seal. That one's a kind of a dead giveaway. Bearings, same thing. It's also nice as you're taking it apart. You're just trying to tear this engine down, and you find a problem. Say this bearing scored. Well, I know that's the second main, so now I'm going to look at that second main cap. I'm going to look at the second main journal and see if that's scored. It's just super helpful to get into that practice of laying everything out as you kind of like a CSI, you know. Here's the cam bearing, same exact thing. That's how I took them out. That was 1, 2, 3, and 4. And if you notice, I could put these against each other. 1 and 4 are actually different heights. I don't know if you can see that, but believe me, they are. This one's a little shorter. And it's the same thing in the back, so they're not the same. Just something to think of. Next up, we're going to install these main bearings. When you get them open, lay them out, make sure you don't see any damage. I already opened these, I can't show you. Here's the package they came out of. They're just stacked on top of each other and vacuum sealed like the rod bearings right here. So if these things are bouncing around, they could get damaged. So you want to lay them out. These look good. I have seen them before where I had to replace them. You don't want to put damaged bearings in, obviously. The smooth bearings without the holes, those are going to go on your cap side. The ones with the holes are obviously going to line up with your oil galleys. So you want to make sure this is really clean. I'm going to clean these one more time. Then I'm going to lightly oil them before I set the bearings in. And then after that, I'll put some moly on the bearings to prepare for the crank to get dropped in. So something else just to point out, which is pretty self-explanatory why you're doing this, but just in case, you have these slots right here that line up with these tangs on the bearings. So those are going to drop right in. And what those are doing, when you add that main cap on top, that they'll have another tang on that, that's stopping this bearing from actually being able to rotate. So when you have a spun bearing, especially like a spun rod bearing, that's exactly what's happening, is that tang is gone on the inside of the bearing, allowing it to rotate. So it's actually spinning around inside the journal with the rod. Just thought I'd point that out while it's apart. So here's the main thrust bearing installed. So when you can see that tang lined up with that slot, and when you press these, push these in, you'll want to line up one side with the edge of that register right there, and then this side's going to be high. These should be sprung out. So you should have to use force to push these down. They shouldn't just pop right in. And when it's down, you shouldn't be able to wiggle them, you shouldn't be able to move them or pop them out. So here's just a view of the rear bearing. Same thing, I lined up this side first. This side was higher. It's sprung, so I pushed it down. It takes a little bit of force to get it down, but now that it's seated, you'll see that there's no gap all the way around. You can grab the bottom of it, and you can't wiggle it back and forth. That's exactly how it should be. It's nice and tight inside that register. A view from the top. And there's your holes lined up. You do want to double check those. All right, get those other two in and move on to the crank. All right, so we got these bearings in on the mains, on the block. I did add assembly lube already. And as you can see, you don't want to put gobs of this stuff on. You just want to put a nice thin coat. Make sure you get your thrust surfaces also. The assembly lube I'm using is the engine assembly lube with moly and graphite. It's made by CRC. Stay Lube. I got this from O'Reilly's. The big deal with this is that initial startup and break-in, you want to have that moly and graphite in between those surfaces. It's basically going to be wiped out in the first 5-10 seconds. It dissolves with the oil, but when you have those pressures in that break-in, this is good insurance to have. All right, I got the crank all cleaned up. I got the crank dropped inside the block. Before I move on, I like to just rotate the crank before even putting the main caps on, just to make sure there's no binding. You don't feel anything, any friction. This feels really good. It's nice and smooth. Doesn't take much effort to turn it at all. And one of the things you're really checking is this thrust bearing clearance. And this one's good. It's not tight at all. It's a little bit of end play. So I think we're good there. I'm gonna work on getting the main caps on now. Just a quick way to show you how these bearings are supposed to fit with the spring tension. The old ones coming out will tell you everything. If you have any issues with your caps or your journals. So as you're rolling, this is the old bearing coming out of the cap. As I'm rolling this out, there's spring tension holding it. And as I continue to roll it and pull it out, you hear like a twang. That's how you know it's still good. And that new one should fit the same way. So I'll just show you here. So what you do is you line up the tang first. Get that pretty flush, the top of that half to the cap. And then you'll see, it looks like it's almost oversized. It's just sprung out. And then as you push this side down, you'll get your fit, and it's a sprung fit. So same thing, I'll roll this out. You could hear it pop out. So there was no issues with this cap or with these bearings. So that's good. I'm gonna clean this up, put the new one in, and you wanna feel for that springness as you push it in. You should have resistance pushing it all the way down. So there's a new bearing installed, no gap at the bottom. Just about flush to the top of the cap. And then for the assembly lube, you're not putting much. That's more than enough. You just want a light coat. Get the idea. Another thing to think about. So I have this one, the front cap installed, and if you'll see, it's not down into the register yet. These are somewhat of a interference fit. So I ran these bolts down. The bottom of the bolts put some moly, so when you torque them, you want to clean the threads of the bolts and then get some moly underneath that head. So when you torque it down, you don't have that loss of friction and get a bad reading. So put some moly under the heads and then just take your dead blow. Run these bolts down, not snug, but just so it can't walk front or back. And then you just take your dead blow until you get it nice and flush. So now it's down inside the register. And then now I can torque that one down. I'm gonna get all the mains in first, all down, all hand tight, and then start the torquing sequence. I got all the caps on, and I have all the bolts ran down hand tight. So all the caps are knocked down, all the bolts are ran down hand tight. And now I like to do another sanity check. Just make sure I'm good before I start torquing them down. And we're all good. Nice and smooth. I don't feel any friction, any skips, anything like that. So I'm gonna go ahead and torque these down, rotate it one more time. If everything looks good, we'll keep on trucking. Got the caps torqued down, 65 foot-pounds for the first pass, and then 81 for the second. And it's nice and smooth. Like butter. So we're good here with the crank. Next stop is getting the pistons cleaned up, rods cleaned up. Then I'm going to start installing those. So let's take all the rings off. I'm gonna soak them in a bath of degreaser, scrub them, re-ring them, and then we'll replace those rod bearings and then start installing these. I have to also bring these heads and drop them off for a valve job at the machine shop. But in the meantime, I got plenty of work I can do. All right, so I got the pistons and rods all cleaned up. I started assembling them. Here's one that's already been re-ringed. Something to think of when these are laying on the bench dirty, you're laying them out in order. Sometimes there's not a mark on the rods. Usually on the cap there will be one. If you see, you'll see I took a center punch. So this is for number 2. So I marked them all. I didn't have any number stamps. So I just used a center punch and I just punched them 1. I put 2 dots for 2 all the way until number 6 here. It's just got 6 punches in it. So these are clean. These are good to go. They cleaned up very well. These have the rings already on them. Another thing too is the direction. So these had the factory arrow on them, so I didn't have to mark direction. But if you also look, there's a dimple on the pistons, on the piston head, right on the by the skirt, by the wrist pin. The other side doesn't have one, so that's also forward. So you got that dimple, and you have the arrow. Something to think of. So for the piston assembly, you want to do the lowest steel. Let me put this down, see if it's a little easier. They come with instructions. The D&Js came with really horrible instructions. They don't really lay everything out, but they're all the same. The bags are numbered, so you have first, second, third. First is your upper compression ring. That's sealing most of the compression. Then you have your second ring, which is probably sealing up 25% of compression, say, and it's also for fine oil control to keep the cylinder walls lubed up. And then your third is your oil control. So your oil control ring has, this is your oil control ring right here that sits in the middle of, we call them steel rails. So you'll have one of these on top, one of these on the bottom, and then your oil control ring in the center. See if I can zoom in. Yeah, you can see it. And you want to stagger them. So you got this first gap here to the side, then 180 is the top gap. You never want to line these gaps up or you'll have a lot of blow by. So you're trying to control that by this top ring. I have the gap here. The second ring, it's 180 degrees out. Then the top oil control steel rail is, you can see it'll be 180 off from that one. And then the same thing at the bottom. This one will be 180 off from that top steel rail. And then your oil control ring, you probably, maybe you'll see it right where my finger is. That's where that gap is. They touch each other, and you want that level with the wrist pin. So for the ring compressor, I'm using kind of this old school ring compressor. They make them aluminum ones for every size. This one's universal, but it's very simple to use. You just drop it in. It's kind of like a ratchet setup. Drop it inside, and you tighten that Allen key up. Set this down here. As you tighten this Allen key up, there's a ratcheting action right there, and it'll just literally compress the rings. And then you'll set it on top of the head. You'll set it right on top of the head, put some down pressure, and then tap the top of the piston with a dead blow hammer, the handle of the dead blow hammer. But what I like to do is get it up on end like this, so you have the rod pointing straight down in the cylinder, so it's not knocking back and forth, kissing the cylinders. They sell some protectors that you can put on the bottom of the rods so you don't nick the cylinder walls. When you put it straight down, light taps, it'll drive itself straight down without scoring the cylinder walls. And then I always rotate the crank so that the lobe is at the lowest point, so I know I'm not going to nick the crank journal. By the time that piston gets down probably halfway in that cylinder, the rod end is already floating around here. So now you can come down to the bottom, finish tapping the cylinder down while you're holding the rod and centering it on the journal. So this isn't torqued down yet. I just take the 3/8 impact gun and just lightly tap them on each side. I don't use a wrench because when we go to torque these, you actually want to put feeler gauges on each side and kind of wedge this rod, because if you could imagine the torque with a torque wrench on here and you start cranking over to the side, you could picture this rod also wanting to twist. You don't want that, so you put shims basically on each side so that it stays square as you're tightening it up and you're not damaging the rod bearing that you just put in there. So that's another tip. You want to keep these square as you're tightening them up. You don't want them twisting on you. Another thing is since we're talking about the rod bearings, I lightly oil the back side. Let's get this guy out here. I just put a little bit of oil on the back side, set that into the rod, and then I use, I've been using this assembly lube for quite a while now. It works good, dissolves in the oil. Then I'll put a light coat on the bearing, then install it, tap it down. Same thing on the bottom. Just take your time with it. Just make sure you're going in the right direction. Your ring gaps are staggered. The directions are correct. The same rod is going into the same crank journal. That's important, especially when you're reusing the same piston rod assembly, which I am here. But I'm gonna continue installing these, see if I can get a rotating assembly, and then keep on moving on. One more thing before I put this in the hole. These two notches right here are your oil drain back holes. You want to make sure those are clean. That's going to stop that oil from sitting in that control oil ring and then eventually baking itself to it, and that'll start giving you piston slap if you seize up that oil control ring, because the oil will leak by that ring, get to your second ring, do the same thing to that ring, and then you'll start getting slop. You want this sprung out and sealing combustion. So here's one loaded piston ready to go inside the compression ring tool. You can see it's cinched right up, so those rings are compressed inside those lands. And now it's ready to be pushed down onto the cylinder and then tapped with the handle on top of the piston to drive this thing down. All right, so we got a rotating assembly here. All the pistons, rods are all in. Just starting the torquing process. Just to give you a visual, I'm starting with number one right here. And if you can see, I got that feeler gauge in there. That feeler gauge, it fits nice and snug. I push the rod away from the rotation, so I'm gonna put that torque wrench on here, tighten it up this way, which is gonna wanna pull the rod in that direction. By putting that feeler gauge in there, it's not gonna allow it to twist and do any damage to that bearing. So I'll do that to this side, and then I'll move it over and I'll put it on the back side over here for the same reason. So as I torque, I'm going to torque the rod against the feeler gauge to not rack the whole rod on that journal and ruin that bearing. So I'm going to do that all the way down the line. Torque specs are 36 foot-pounds. I'll torque these down, roll this engine over, and see how good it rotates, and then we'll keep on moving on. All right, guys, so we got a rotating assembly complete. Mains are torqued down, the rods are torqued down. Everything feels good. Rotates nice and easy. I don't feel any binding, no weird sounds. So I'm gonna end this video here. I'm gonna do this in stages, kind of like the Camaro build. I have to order some more parts, some lifters. I gotta get the heads cleaned up, get a valve job done, valve seals. So in the meantime, I'll upload this. If you found this video helpful, please think about subscribing and give it a thumbs up. That'll help me a lot, and I appreciate it. See you on the next one.